Hello everyone, welcome back. We will discuss recurrent neural network today, or in short, it is known as RNN. So, the important part of it is that it deals with sequential data to make predictions. So, ultimately, the purpose of neural network is that I'm going to supply some input and it is going to generate some prediction for me. And the specification about recurrent neural network is that it is going to handle sequential data. Now, before going to RNN, we'll try to understand exactly what is sequential data and how it gets processed. Now, what is a sequence? It is a particular order that one thing follows another. That's a sequence. And the example of sequential data, it is like audio file or some text file. So it is something that where everything means is the component of audio or component of text, it is coming in a particular sequence. And you will agree that human being always remembers the common sequences, say the alphabets, or the numbering system, so as you learned the sequence, the uh, general sequence, say A B C D E F and so on, so you remember that sequence. But if I just change the order of different letters in the alphabet, then it may have some different sequence, and it will not be possible for us to instantly just see it and memorize it. For that, we have to maybe go through it multiple times so that it will be there in our brain. So we always have some sequential memory. So if we have some sequence, known sequence, then it is like we always remember that. That is how the human brain works. Now, how this RNN works, it is also like able to memorize some part of the input. Like human being, the RNN can memorize some part of the input, and that is used to generate the accurate predictions. We will discuss with some examples so that things will be clear. Now, it has some kind of looping mechanism, means it is like the for loop, say in a C code. So we have some for loop. For loop means that it starts with a value, then it executes whatever is there within the for loop. Then once the code inside the for loop is executed, then it again goes back to the for loop and starts the processing again and again. So this type of looping mechanism is there in RNN. Okay, so it's like something that the information, maybe some data, it is going to be flown in a chain of events. It's like a looping for loop. So it is like executing in that way. Now, the common application of RNN is in speech recognition, language translation, stock prediction, and so on. So, generally, whatever the nature of the data, it is something which is kind of sequential, and where the way the inputs are coming, the sequence the input is coming, if that is important, then RNN is the type of neural network which can help us to generate the predictions. So you know that, as I told, that there are many types of neural network. So every type of neural network has a specific application. If it is sequential data kind of, and you have to generate some prediction, then RNN is the most suitable choice. Okay, now we'll try to explain it with an example. Say this is a question, very common question that is being asked, that what is your name? If someone asks me this question, then I try to understand that how the words are coming, like what is your name. So I understand that the person is asking me the name, and whose name? Your name. And what is, maybe name is always constant maybe, but if just for assumption, if you assume that maybe I change my name every month, say, so if it is like what was your name, so maybe I have to think that what was my last name, but means last time what was my name. But when it is the question is what is your name, then I understand that the person is asking me the current name I have. So you can understand that to answer this question, it is important that I should listen to every part of this question, right? So if it is only name, then I cannot understand that whose name is being asked. Then if it is your name, so I understand it is about my name, but exactly what is the question I cannot understand only by listening your name. So it is important that I should listen to the entire question, that is what is your name, then only I will be able to answer. So RNN also works in this principle, means if you really say you are supplying this question to the RNN to maybe say to generate the outcome, it is important that the neural network has to understand the entire question. If it is not, then it is not possible to generate the answer. So RNN works on this question, generate the outcome, but how? So we'll discuss the working principle. Okay. Um, exactly this what is your name can be processed, that also we'll discuss. Now, what is the working principle? First of all, it initializes the input, output, and hidden layers. Now let us go to the paint where we'll try to draw this. Say this is my input layer, then I have the hidden layer, and I have the output layer. Okay, so that is how I have designed my network. So input to hidden, hidden to output, and from output layer I'm generating the prediction. Okay, so this is my input, this is my hidden, and this is my output layer. Okay, so that was my first step. Then I initialize the hidden state. Now this is something which is going to be very important as part of RNN, because you know that here only processing word by word processing is not sufficient here, because when I'm processing the different parts of this word, say what is your name, then it is important that I have to remember all the parts of the question to answer it. So RNN has some quality where it can process, say now for instance we are assuming that it is processing the multiple words. So whenever it is processing the word, it can remember the earlier words as well, then only it can generate the prediction. So to remember the earlier words, it is maintaining the hidden state. So I have to initialize the hidden state. Of course, you know that as I'm starting, so hidden state has no value as of now. So maybe I can just create one, you can say one array of zero values initialized. Okay, so it's like something like that. So here as we have four words, so maybe I'm just creating one array where I have four zeros. So that is my hidden state. Okay, I'm initializing the hidden state. So that is my hidden state. Now I'm looping through the inputs. So here I will do the processing word by word. Okay, so as I have four words, so maybe I'm just going to run the loop four times and pass the first word and the hidden state. So it's like something you can say that when it is going to the hidden layer, the first word is what. So it is what is the input is just going to the hidden layer for processing. First of all, this is the word what that is being sent, and then the next thing is this hidden state. Okay, so now it is empty. So these two things are getting as input to the hidden layer. So what the RNN does, it returns the output and the modified hidden state. So from this hidden layer, some output is getting generated and some hidden state is generated, which is actually sent back again. So that's why we are talking about looping mechanism. So here what it is sending? It is sending the modified hidden state. Now what is the modified hidden state? Maybe instead of 0, the first element is now what? So this is the modified hidden state now, where I have this word what, then I have 3 zeros. So that is being again sent back to the hidden layer. And what is the next word? Next word is. So in the second part of the loop, you know that how the loop works for each and every item. So that was the first item that was sent to the loop, and is the second word that is being sent to the loop. Now what is being sent? Now there are two inputs. One is this word is, and another is this modified hidden layer that is being sent to the this hidden layer. Now this again, it generates some outcome. If I try to do it with this different color, so this time this is the outcome, and again it is generating some hidden state, modified hidden state, that is being sent to the hidden layer. So what is the modified hidden state now? It is what and is, and then rest two are 0. And what is the next input? If I just give here number 3 input is your, right? So that was the third iteration of the for loop. Say if I just assume it's a for loop, so in the first iteration I sent what, then is, then your, and in the fourth part it will be sent as name, right? And when name is sent, then what is the hidden state? Hidden state is something what is your, right? And when the outcome is generated for the last part of the loop, then it has the entire content, that is what is your name. So when the outcome is generated, it is remembering every part of it, every part of the question, that is what is your name. Then maybe it can be sent through another layer, say the output layer, where this question is processed and the outcome is generated. Say my name is X, so this is the outcome. So that is how your recurrent neural network works. It's a simple example. It's not that easy, not that simple, but the working principle is this, that first of all you start with the different layers, you generate one hidden state which is initialized, and then say if it is a text data, if it is a sentence, then you are just sending the words one by one and the hidden state. So whenever the processing is being done, I'm not only processing with my current input, but I am processing the input along with the hidden state, which contains nothing but the past information. Means the when I am processing the sequential data with my current input, I have information from the earlier stages of the sequential data, right? So continue to loop for all the words, pass the output to the feed forward layer to return a prediction. So feed forward, you know that when I am not giving anything back, I am just sending information from the earlier layer to the next layer. So when I have done this processing of all the words, then I can just proceed the information to the next level, so that the entire question can be processed and the data can be used to generate the prediction. But this RNN has some issues also that we'll discuss. Okay, so that problem is known as short-term memory. Okay, so to understand short-term memory, we have to first discussed vanishing gradient problem. We already had some part of it that we covered of vanishing gradient. So vanishing gradient is nothing but that when you have made some change, but it has almost none or very minimal reflection. So that is the vanishing gradient problem. When we discussed activation functions, we talked about vanishing gradient problem. Now here also we face the same type of issue. Now why? That we have to discuss. Let us go back to the diagram again. Okay. Um, I will just come to a new canvas. So you know that again, if I just write the question, that the question was that what is your name? So if it is a small question, then we can remember, right? We remember the entire part of it and then we answer. But say suppose one person is asking me a question, so I'm trying to listen what is the question, but maybe it is very big, the question is going on. Then what is the difficulty generally we face, that we cannot remember at once the entire question. So most of the time we ask that, can you please tell me again what was your question? Or maybe we sometimes we ask that, can you ask in parts, means can you ask me the question in part by part, because it's not possible. Generally it's not possible for us that if someone asks me a very long question, then we cannot remember the entire thing. And what happens that when we listen to a very large question, then most of the time we forget about the initial parts of it. We only remember the last part of it that is being asked, like. So that is known as the short term memory. Means we also have some limitation. If you ask me what is your name, I can remember. But if you ask me what is your name, what is your address, what is your age, where do you live in, where you are from, which school did you study. So if you ask me so many things, then it is very much possible that I cannot remember each and every part of the question. Generally we forget about the earlier parts and we remember the last part of it, and then we try to answer, right? So that is happening with human being, and that happens with RNN also. So just assume that if this is the question is being asked to you, and if you remember only this part, then what will happen? You are only remembering from the question the name. Then you cannot understand, right, that what name it is about, whether it's a person's name or place name or something. But if you say, if you at least remember your name, so you understand that okay, it is about my name, the question is about my name. But this part is also important, right? So if you don't know what is the initial part of the question, that is what is, so it will be difficult for you to answer, because only if you remember your name, then it is ambiguous, right? As I gave you the example, say I change my name every day. So whether the question was that what was my name yesterday, or what will be my name tomorrow, or what is my name today. So that's why you can understand that to give accurate answer, I have to remember the entire question. So for RNN also the same thing. If it has to generate accurate prediction, then it has to remember the entire question. But as you know that every time when I am processing the input, I am taking the hidden state, right, as an input, right? So but if it is a, the hidden state is huge, then the impact will also be going to be less, right? Means ultimately it is your memory. So say if it is the entire part of the question, say this part has this name part, okay? When I'm at the end of the stage, means I'm just doing these things, and what is happening, that most of the part what I remember is name. Then I am remembering this your part. Then there is and what. So you can understand that this what, it has a very low portion here, because we cannot accommodate the older ones much. Most of our memory is being occupied by the last things. So that is also being done here in RNN, because in RNN what is happening, we are updating the hidden state, and it is like the back propagation as we discussed earlier. So it is through back propagation it is being done. So when you just follow, means when you just process or flow the information, then what is going on, that the hidden state that was long before it was done, because it is like the information, as it is a sequential data, it is like back propagation through time. So the information that was sent, maybe the fast part of it, of the hidden state, or the earlier parts of it, that has less impact on us, right? So if someone has told you some important information today, you can remember it well. But if some information was told to you maybe 1 year back, then what happens? Our memory, we cannot keep so many things in our memory, right? So it gets faded. So here also the same thing, as we are going on, then long range dependencies means, when it is a long range dependencies across time, then RNN is not able to learn. So as a result, what is happening, the if you just take the example of the sentence that we are talking about, so it is giving more importance to the last words, maybe last parts of the sequential data, and the earlier parts of the sequential data gets less importance. So if that is the case, then what is happening, that it has the impact on the prediction generation. So for overcoming this problem, because here it is important that instead of only not only the latest input we have to remember, or we can forget the earlier information, that is not like that. But here what is the important thing, that whatever may be the sequential data, to generate the accurate prediction, it has to remember each and every part of it, and it has to give importance to the important part of the sentences. Sometimes you will find that when people talk, maybe in a sentence there are some keywords, right? We always talk about keywords, that maybe some of your friends are talking many things to you, but you have to identify that what are the keywords that he or she is trying to say. So here also the same thing, if RNN has to process it, then it is not only the entire thing it has to remember, but it has to give importance to some part of it. Maybe the fast word that was being said, that is the most important one. So if it is lost, if it is due to short term memory, if it is lost, then the prediction generation is not possible. So that is the problem that is being found in RNN. And for solving this, there are some two ways where you can say it is a modified RNN. So these two systems are known as long short term memory, or LSTM, and gated recurrent unit, or GRU. So we'll stop here, and in the next session we'll discuss on LSTM and GRU. So for now, thank you.